mark, mark.
The spacecraft were actually rovers, robotic vehicles capable of traveling across the Martian surface and poking around.
The rovers are robot geologists. Their job is to be our eyes, our feet, our hands on the Martian surface. We experience Mars through them. They can reach out and they can touch rocks. There's this device called the RAT, R-A-T, the rock abrasion tool, which is a diamond tip grinding tool that we can use to grind into the interior of a rock, and so we can actually get a window inside the rock. They have sensors on the end of that arm, like there's a microscope for telling us in detail what they look like. So we've got a whole bunch of tools similar to what a geologist would want if they were actually physically there on the scene.
The rovers were named Spirit and Opportunity, and they are still exploring regions of Mars today at locations on the planet hundreds of miles from each other. Spirit landed in an area dubbed Gusev Crater. The crater is believed to be a dried-up lake bed, so if the water it once held contained biology, Spirit might uncover signs of it. Opportunity touched down in a region called Meridiani Planum. The area is intriguing because it contains an ancient layer of hematite, an iron oxide that on Earth usually forms in a spot that held liquid water. So far, neither rover has found signs of life. But both Spirit and Opportunity have uncovered ample proof that liquid water was once plentiful on the surface of the red planet.
We've seen places where water soaked the rocks beneath the surface. We've seen places where water came to the surface and flowed over the Martian surface, creating little ripples that are still preserved in the rocks billions of years later.
But neither rover is close enough to the tundra-like Martian poles to uncover actual frozen H2O. That is the primary goal of a new mission to Mars, launched in the summer of 2007. This mission is dubbed Phoenix, and its plan is to place a stationary lander in the region of the Martian North Pole. The lander has a sturdy robotic arm equipped with a scoop. Phoenix will excavate the polar soil. Dr. Peter Smith of the University of Arizona heads up the project.
Our entire scientific mission is about understanding the properties of the soil and its interaction with the ice, and the properties of the ice and the ice interaction with the atmosphere. We have only one way to study it, and that's by using our robotic arm as our backhoe, if you like, that's going to dig a little trench and provide samples of both soil and hopefully wet soil, if we can find it, and ice, and we will analyze those samples with instruments on the deck of our spacecraft.
The lander will beam signals back from the Martian surface, reporting the results of the remote soil and ice analyses. But before Phoenix has even had a chance to make it off the launch pad, a new wrinkle in the saga of water on Mars has revealed itself. Images beamed back from a spacecraft currently orbiting the red planet show evidence of a very unexpected event. It appears that a liquid flow of some sort has occurred within the last few years in a small gully at the edge of a deep Martian ravine. In 2001, the orbiter took photos of the exact same spot, but nothing of interest showed up in those shots. The new photos, on the other hand, showed a white residue in the gully, a residue seemingly left behind by a flow of liquid, possibly where water spurted from the ground and flowed for several hundred yards before transforming into vapor and vanishing. Scientists do not yet understand what might have caused such a flow, but many suspect that it's a result of some form of internal heat the planet must still contain.
Clearly, it's a planet that's been volcanically active. And all of us are very hopeful that some places on Mars we could find hydrothermal vents. And not just because we want liquid water, but because the liquid water implies that this might be an environment that life could develop or be maintained.
It is, of course, all about the search for life. When all is said and done, the engine driving all of the astonishing scientific effort to explore the red planet is the burning desire of humankind to know if life exists elsewhere in the vast reaches of space.
I think humans have, since the dawn of consciousness, wondered why they're here, and wondered what's up there, and wondered if there's more. And answering that question will sort of put us in some kind of perspective. It'll tell us what our place is in the universe to some extent.
Finding life on Mars could also help us understand the origins of life on our own planet.
And there could actually be, in the case of Mars and Earth, a significant connection. You know, if Mars developed life itself, maybe the conditions were right on Mars, but they weren't right on Earth. But yet Mars seeded our planet. Perhaps through meteoritic collisions, pieces of Mars arrived on Earth. With cells of life, and that actually grew here. Maybe we could all be Martians. Or perhaps it was the reverse, you know. Perhaps life originated on this planet and moved to Mars.
If we find evidence for life on Mars, and we know there's life on Earth, of course, then there's probably life all over the place. The universe is probably teeming with life. And if it didn't, then it makes us feel, I think, a little bit more special.